I'm actually doing this talk on behalf of Megan Dalton, who is the lead editor for the report, and she is really responsible for a lot of the good work on this. So there have previously been some Northwest reports on climate change, and I'm omitting. I know that there were some earlier reports before 1999. For instance, I think EPA had a kind of initial look at what climate change was going to mean. But as part of the first national assessment, again, all of the regions, at that time we were operating with 19 regions, almost all of the regions produced a regional report, and the Northwest report actually was the first of the set to come out. This time we're among the last. The Climate Impacts Group at University of Washington, under contract to the state of Washington, produced the Washington Climate Change Impacts Assessment in 2009. My institute, OCRI, Oregon Climate Change Research Institute, is required by law, sort of like the federal agencies, to do a report, in our case, every 2 years on the state of climate science as it pertains to Oregon. And we looked at the Washington report and sort of let things drift south of the boundary, because that was a lot of the recent work that had been done. And Kathy Dello, who's sitting here, produced that report in very fine fashion with about 75 authors. This is the cover. I just received the proofs for the report on Tuesday. So next Tuesday, I've blocked out the day to sit on my deck, or if it's too cold, I'll sit in my living room and read all 270 pages and see what mistakes have crept in through the editing. Megan Dalton, as I already mentioned, is the first editor. Jennifer Howard is with Island Press, and then me and Amy Snover. And we have a great team of people who have contributed. And I'm highlighting in red the people who are also the authors on the Northwest chapter of the national report. So a very wide range of affiliations and really great group of people to work with on these various chapters. So the climate chapter, we're going to use global and regional models. Kathy mentioned the regional scenarios that Ken Kunkel developed. So our climate chapter is based in part on those. We want to estimate uncertainties, try to give a sense of how much we know and how well we know it. Main uncertainties are, of course, the greenhouse gas emissions. So we look at the SRES scenarios, and which is the 1999 era scenarios of greenhouse gas growth, and also the more recent RCP, representative concentration pathways. The second source of uncertainty is the climate response, and different global climate models warm up different amounts if you gave them the same amount of greenhouse gases. So that variation in climate response probably is a rough estimate of the actual range of unknowns in the real climate system. So some of you saw versions of this figure yesterday, or gosh, it seems like yesterday. I guess it was this morning in my talk. This is a different representation, but this shows the simulations by global models of the second half of the 20th century. That's the gray shading. The actual trace, a smoothed trace of regional temperatures is in black. So you see they're sort of representing roughly what happened, warming that began maybe around 1960. And then going forward, it matters whether the human race chooses the lower emissions path represented by the blue RCP 4.5 or the higher emissions RCP 8.5. So you see individual models as the thin traces, the thick curve as the average of all the models. And for RCP 8.5, the way it's constructed, our climate actually starts to stabilize toward the end of this century at a regional warming on average of about 6 degrees Fahrenheit. But notice that the range of what individual models project for 2100 goes from about 2.5 degrees Fahrenheit to about 8 degrees Fahrenheit. So very wide range of uncertainty just for that given scenario. And then maybe we won't get our act together, and states that have set greenhouse gas emission targets like Washington, Oregon, and California will miss them, and others won't do anything, and we'll just burn lots and lots more coal, and we'll be on the RCP 8.5 path. And that would give us temperatures more in the range of 8 to 14 degrees Fahrenheit. And just imagine the future of the ski industry and irrigated agriculture and so on, which we'll come to shortly. Notice that these scenarios don't substantially diverge until about 2030 or 2040. So there's this very slow flywheel of production of CO2 that our economy has, so that if we really hit the brakes now, it would take a while for that to take effect in the climate of the region. Not just global modeling, but also regional modeling went into the climate chapter. This is from Ken Kunkel's work with the North American Regional Climate Change Assessment Program, NRCAP. Individual regional models as indicated by the column on the left. I'm sorry, I blew this figure up as big as it would go, but it really belongs in print, so sorry you can't read. It doesn't, the names don't really matter. The point is, these are different combinations of regional models and global models for mid-21st century minus late 20th century. So the symbols indicate the changes in the 1 in 20 year one-day precipitation event and the 1 in 50 year one-day precipitation event. So you can see there's one regional global model combination that says that extreme precipitation will decrease. The rest say it will increase. If you average all the models as sort of a rough guide to what we know, you get about a 10% increase in the 20 year and about a 13% increase in the 50 year. So, this isn't a doubling of extreme precipitation events, but it may be significant. So just summarizing the future climate part, warming's underway. It's going to be warmer in all seasons. There's a wide spread in how much warming. What I said about the divergence of scenarios of warming depending on changes in greenhouse gas emissions now. And summer, I didn't point this out, but of the seasons, the models seem to want to see the summer warm more than other seasons. Now, just taking a step back, with that climate context, we had a workshop here in Portland a couple years ago to follow the guidance we were getting from the national assessment to move beyond just describing climate impacts, but to actually do a risk framing approach. And so we worked very hard to estimate the likelihood and consequences of different kinds of risks. And the framework for it came from the Oregon Climate Change Adaptation Framework, which was a companion to the climate assessment report I mentioned earlier, involving a lot of state agency folks. In this case, we went beyond just Oregon. So the intention was to rank the likelihoods and consequences and to recognize the expertise that lies outside the academic committee and community, and to get to draw on the knowledge and experience of people more in the management realm. One of our goals was to build capacity for a sustained regional assessment process, so you see how this congruence between regional and national goals. This is sort of the one-sentence version of this 270-page report. Key regionally consequential risks in the Northwest include impacts of warming on watersheds where snowmelt is important, coastal consequences of sea level rise combined with other stressors, and the cumulative effects of fire, insects, and disease on forest ecosystems. So those are kind of the big three that we identified. We did look at agriculture, and we concluded that there is substantial adaptive capacity inherent in the economic framework of Northwest agriculture, and that there are benefits and as well as risks to agriculture. And so it did not rise to the level of being one of our top concerns. Not that it isn't important regionally, nor that it won't be affected by climate change, but it didn't carry quite the same weight of risk. The big story, a lot of it derives from these shifts in stream flow that you may have seen in several talks during this conference. This is simulated flow for the Yakima River, 20th century in black, and then with successively greater amounts of warming, you see the summer peak flow diminish to the point where by the 2080s scenario, it almost looks like a rain-dominant watershed. And this is not for that 8.5 scenario that I showed you earlier. This is a slightly more modest warming scenario. So you start thinking about how much of the stream flow east of the Cascades originates as snowmelt. If you don't have snow, you won't have the flow. And it's already happening. This is this is some work that was published in 2011 showing trends in the June stream flow as a fraction of the annual flow. This is a figure made specially for our report, but it came from a paper. So the browns are stream gauges that are showing reductions in June flow. And so you see most of the Northwest, with the exception of the rain-dominant watersheds in Southwest Washington and Western Oregon, most of these are seeing shifts of sort of 5 to 10%, some even more over the last 60 years. So it's already happening. This is work by Luce and Holden, summarized in a maybe more user-friendly way. This is looking at the 25th percentile of annual flow over roughly the same period. It's the number of stream gauges with significant in maroon and not significant in blue. None of these stream gauges showed an increase in the amount of the lowest flows. So the lowest flows are getting lower over time in every stream gauge in the region. So what about sea level rise? I'd chalk it up to another crazy backyard hobby, except he's the world's leading authority on global warming. Kathy showed you some very compelling images. You know, should we go build an ark? We used the National Research Council report on sea level rise for the West Coast. Very broad range of uncertainty, very carefully calculated, incorporating both local and global effects. The two biggest sources of uncertainty are we don't know what's going to happen with the Antarctic ice sheet, how much it's going to melt, and we also don't know where the greenhouse gas emissions are going to go. And that, of course, has consequences. All sorts of cities on coastlines are making maps like this. Much of the industrial harbor area of Seattle is within the range of sort of the higher end of the scenario that I just showed you. Forest risks, I already mentioned the fires and insects being a big concern, and this is already happening. These are from data over roughly the last 25 or 30 years. Areas burned by fire in orange, affected significantly by insects and disease in brown. So most of the region, especially Idaho forests, have been pretty hard hit. Western Oregon and Western Washington relatively spared from these two threats, although not immune to other diseases like Swiss needlecast. Jeremy Littell had produced this for another NRC report on sort of scaling the impacts of climate change with the amount of total global warming. And so this is the estimates of the future change in median area burned, and the forests of western Montana and Idaho are projected, based just on the observed relationship between temperature and area burned, to see the largest increases. But even the more mesic or kind of wet forests of western Oregon and Washington also projected to see large increases in area burned. All sorts of concerns associated with that loss of timber production. We're already seeing a substantial loss of subalpine forests and also air quality. Agriculture, as I mentioned, not so much concern. Longer growing seasons, a good thing. Drought stress, a problem. CO2 fertilization, a big plus. But the big kahuna in some basins is this loss of snowmelt-driven flow in the summer. And there are all sorts of impact pathways in the agriculture sector, which are outlined here. Human health, there's a lot of different pathways to do with air quality, air pollution, direct effects on human physiology, and so on. We're rapidly moving to an unfamiliar environment. There are both risks and benefits of change. The report kind of focused on risks because that was how we started as a, let's just do a risk framing exercise. But, from an adaptation standpoint, being proactive, we can minimize risks and maximize benefits if the change is slow, i.e. we limit emissions, and also if the consequences are more anticipated. Thank you.